Okay, so let's talk about necessary and sufficient variables. Very few variables are necessary to an outcome and sufficient to produce an outcome. Necessary means that you have to have that factor present in order to display the outcome. The gene for Huntington's disease is an example of a necessary variable. If you don't have that gene, you won't develop Huntington's disease. Sufficient refers to that's all you need in order to produce the outcome. Again, the gene for Huntington's disease is a good example because all you need is the gene for Huntington's disease. It's sufficient to produce the outcome. And you must have the gene for Huntington's disease in order to experience the outcome. A few variables are like that. I had to reach out to a genetic disease to come up with something because so few things in psychology are like that. I mean, so few outcomes that we are interested in psychology are outcomes that we know there's a single cause. It will always produce the outcome, and it's all you need in order to get the outcome. There are very few variables like that for us. There's something that's a kind of good example, which is how we get schizophrenia. We don't know how you get schizophrenia. Literally do not know. But there are some things that we're studying right now. One of them is the role of the flu virus in the development of schizophrenia. So I think I told you about this in a previous lecture. If mom is exposed to the flu virus during a critical period in gestation, when she's carrying the baby, there's a higher probability that that baby will grow up to have schizophrenia than if mom had not been exposed to the flu virus. But the flu virus is not necessary for a person to develop schizophrenia, because there are people who have schizophrenia whose moms never had the flu during gestation. It's not sufficient. It seems like at the minimum it has to happen in combination with this critical period in fetal development during the organization of particular structures of the brain. And even beyond that, we're not entirely sure that any time a flu virus is present at that critical period, that combination would be necessary and sufficient. It might mean it might be the case that there's you're required to have a predisposing gene or something too. It's really not well understood, and that's so characteristic of things that psychologists are interested in. There are multiple factors. Hardly ever is there a thing that will cause an outcome in psychology. So that's why we use factorial design so often, because if you use a factorial design, then you can factor in one factor will be whether the person was exposed to the flu virus during gestation, yes or no, and then how old were they? Were they in the first trimester, second trimester, or third trimester, right? And then we can look at the differences in their schizophrenia scores. By taking both factors into consideration, we have a better chance of making a prediction. Okay, so let's assume we've got a couple of factors that we think are going to have do a pretty good job of causing a particular outcome. Okay, how do we get our participants into their experimental groups? Well, there is one technique that's called creating independent groups, or we sometimes call it a between subjects design. What that means is that in this strategy, the groups are going to contain different members. So nobody gets retested or anything like that. So here's an example of a between subjects design. What you're looking at here is on the x-axis, we have different groups of people. We have a group of 25-year-olds, a group of 32-year-olds, a group of 39-year-olds, 46, 53, yeah, I'm doing some math, sorry, it's every 7 years. I don't know what's wrong with my picture. All the way up to 81. So these are each different groups of people. Okay, on the y-axis we again have the dependent variable, which is going to be their t-scores on all these different cognitive tests. So we've got inductive reasoning, spatial orientation, perceptual speed, numeric ability, and verbal memory. And so what they've done is they've graphed out the average score for each age group. The one that I'm following right now is verbal ability. Okay. Verbal ability and numeric ability seem to be pretty stable across the lifespan. They seem to increase until about 39, then they seem to be reasonably stable, a little variability across your lifespan. All the other ones seem to be the highest when we're youngest and the lowest when we're the oldest. It looks like with spatial orientation, perceptual speed, what have we got else? Verbal memory, and inductive reasoning. We've got a pretty steep decline in functioning across the lifespan when we do this independent groups between subjects design. If you've had lifespan development, you might have learned this is called a cross-sectional design. Another way to collect data is to use the same people more than one time. We call this a correlated groups design or a within subjects design. This is when we test the same participants in each condition. So each participant's going to serve as their own control, basically. Okay, so this is the exact same data, but now instead of having different groups of participants, what we have is the same people being tested at 25, retested at 32, retested at 39, 46, and so on until they're 88. This is actually data from the Seattle longitudinal study that was started in the 1930s and has been ongoing every 7 years since then. And they always produce the cross-sectional data, and then they also provide the longitudinal data. And one of the things that you'll notice really dramatically changes between the cross-sectional and the longitudinal or the within subjects design is that you see fewer of these just steep decline kinds of outcomes. Most of our abilities are very consistent across our lifespan with some declines as we get older. This yellow one is numeric ability, and it seems to drop off for some reason. The one thing that follows the same pattern in the cross-sectional technique as it does in the longitudinal technique is perceptual speed. And that may be a function of normal aging of our eyes, our ears, our reaction time slow as we age, and that's really not subject to a lot of input from the environment. That's just that's a function of aging. Everything else, there are environmental factors that cause the cross-sectional data to perform one way and the within subjects design to perform a different way. So when we're assigning participants to groups, one of the first things we have to wonder is, am I testing something that I think is so consistent across people that it's going to be fine to test different people in each condition? Will that be fine? Or do I feel like I'm testing something that might have a lot of individuality, a lot of variability between people? Maybe I want to go with a within subjects design. So we use between subjects when we feel confident that that it's safe to make comparisons between people, that individual differences won't be that important. We use the correlated or within subjects design when we feel like there might be a lot of individual difference that would matter. I had one more thing I wanted to say about this topic, by the way. Within subjects designs tend to give us, again, a lot more power. And so by allowing participants to serve as their own controls, by allowing participants to be tested and retested, we can actually get a lot of times better insight into the real pattern of the data. However, one of the complaints about the Seattle longitudinal study is that we may be getting an artificial impression of how good our intelligence and cognitive skills will remain in our older age, because one complaint is that the participants are taking the same test every 7 years, and that they might just be providing the same answers. By the end, they've seen this test so many times, they might just be providing the same answers and not really showing the same inductive reasoning, not really showing the same verbal ability. it might be a practice effect. And that's a real concern within subjects' designs, is that if you're going to test the same people more than once, the act of testing them the first time might impact their performance on the next test that you're administering. So it's not just a simple, well, I'll just always go within subjects, that's the safest. Sometimes you have to go between subjects because you'll, what we call taint, T-A-I-N-T, taint your participants by doing the initial test. So you really have to think this stuff out. Okay, I'm going to go ahead and take a break here, and we'll come back and talk about how to